explain the construction of a transformer. Let's first take a look at the basic elements of a transformer. It consists of a primary coil, laminated core, secondary coil, and a former. Primary coil is connected to an AC supply and a load is attached to a secondary coil. Between the primary and secondary coils, the coil which has high voltage across it is called a high voltage coil, and the coil which has a low voltage across it is called a low voltage coil. Note that high voltage coils are thicker than low voltage coils. Now let's briefly describe each of these elements. Low and high voltage coils windings are made up of copper wire covered with a varnish insulation in order to separate or insulate the iron core and the windings as well. Laminated core is made up of high permeability silicon steel. In order to reduce the eddy current losses, it consists of the layers of thin steel plates which are insulated from its neighbors by a heat-resistant enamel insulation coating. Depending on the type of transformer construction, the laminated core may consist of a plate of shapes E, I, U, and T, and a former is usually made up of a plastic. It provides support to the windings. Now let's construct a transformer using these basic elements. Let's assume that the number of turns required for a low voltage coil is T1 and the number of turns required for a high voltage coil is T2. In general, on the basis of construction design, a transformer may be classified as core type transformer and shell type transformer. Let's first construct a core type transformer. Take two plastic frames. On each frame, wound T1 by 2 turns of a low voltage coil. Followed by a tape to provide insulation. Then over these two frames wound T2 by 2 turns of high voltage coils. Followed by a tape. To form a core. Then on each frame connect 2 low voltage coils in series, leaving the 2 terminals that form either the primary side or secondary side of the transformer. Similarly, on each frame connect 2 high voltage coils in series, leaving the 2 terminals that form either the primary side or secondary side of the transformer. Thus, we have the core type transformer as we see that it consists of 2 yokes and 2 limbs. Let us now construct a shell type transformer. First, wound a low voltage coil and a high voltage coil on the plastic former alternatively. Then insert either the E-shaped and I-shaped steel plates or U-shaped and T-shaped steel plates into the frame to form a core. Here, let's insert the E-shaped and I-shaped steel plates. Then connect all the end terminals of the low voltage coils in series to form one set of end terminals. Similarly, connect all the end terminals of the high voltage coils in series to form another set of end terminals. These end terminals form the primary and secondary coils of the transformer. Thus, we have the shell-type transformer as we see that it consists of 2 yokes and 3 limbs. Note that coils are wounded around each other in order to minimize the effect of flux leakage and the strength of insulator used between the coils.